Okay, this video is going to be drawing ray diagrams for concave mirrors. In all of these, an arrow will be our object. The principal axis is provided with the locations of the center of curvature as well as the focal point. So we're going to go ahead and get started. Now, using our two rules for reflection on concave mirrors, I can choose a point. You're working with sort of a big stylus here, so bear with me. A point at the top of my object, and I can go parallel to the principal axis that reflects through the focal point. And I can do this again with an incident ray that goes through the focal point and reflects parallel to the principal axis. And I can check my work using a, well, not doing very well on this one, a ray, yep. There we go. An incident ray that meets at the vertex, and then I can approximate its location back. Now, of course, you would be doing this with a straight edge and not with a big stylus on an iPad. So we can imagine that our image is located here. And with all of these, we're going to be having the bottom of the image located on the principal axis, and notice that any reflection from there would allow us that, like, all of those would intersect here along the principal axis, so we know that this image is upside down. So, what conclusion can we make? We can conclude that images formed by a concave mirror when the object is what we say is beyond C, it's behind C, further away from C, that image is located between C and F. And this will be true of all objects behind C. It is a real image, right, because it's in front of the mirror. It is inverted, meaning it is upside down. And it's actually smaller or reduced in height, right? This image arrow is smaller in height than the object was. Okay? Next one. If you want to try these by yourself and you have notes at home, I would say pause me now, try it, and then come back with me to check your work. So, we're going to choose our point at the top, parallel to the principal axis, back through the focal point, and again, incident ray through the focal point and back parallel to the principal axis. I'm a little off. We'll see. And again, I'm not doing this with a ruler, so mine might be slightly off from where it should be. And it should be that for an object at C, the image is located also at C. So the image is at C also. It is the same height as the object. It is still inverted. And of course it is a real image because it is located in front of the mirror. I realize I did not do one of these as well. So, yes, I'm not doing it perfectly, but you get the idea that that is where the image should be located. Now, we are going to be dealing with an object that is located in between C and F, as denoted here. Again, taking our point on the object, parallel, reflects through the focal point, through the focal point, reflects parallel. Okay? Again, we could take a point at the vertex, and we end up getting an image that ends up being sort of somewhere out here. Now, what are the properties of this image for when the object is in between C and F? Well, for our image, it is located beyond C, right? It's further away from C. It is therefore also real. It is still inverted. And it's actually enlarged or magnified, right? Notice the height of the image in comparison to the height of the object. Next one. This is particularly an interesting one. So, now we have our object is located between F and A, the vertex. And if I imagine sort of something that would pass through the top here, right? It's still in line with the focal point. Right? We're in line with the focal point. We will reflect parallel. And again, if we reflect sort of an incident ray that reflects parallel, we will reflect through the focal point. And you might be saying, well, what's going on here? Because in order to have an image, you need to have light rays converging. These light rays are diverging. However, you could follow these light rays through their lines of sight, and their lines of sight end up converging. And this is very similar to what we saw in a plane mirror. And in fact, our image produced when our object is in between F and A will actually produce a virtual image that is located behind the mirror, therefore obviously virtual image, that's sort of redundant, and it is upright, it is no longer inverted, and it is enlarged. It has been magnified. Okay? Another one here is you could say, okay, well, what about this one? Would reflect back through C, and again, line of sight would go through there. Last one, an object at F. So we can say, okay, point at the top, parallel to the principal axis back through F. And then maybe we could do one through C, because we can't really go through F as an incident ray, we're already there. But we can do one through C. And what do you notice about these rays? Well, you'll notice that they are parallel to each other. And if they're parallel to each other, whether you extend them past the mirror or talk about them in front of the mirror, they will never converge. And this will be true of whatever point we choose on here. They will never converge. and the way that they're going to reflect if they're located at the focal point. And so what you find is that we will actually get no image when the object is located at the focal point on a mirror. And those are ray diagrams for concave mirrors.